This video will use a couple of examples to demonstrate the process of graphing a sine or cosine wave given the period, the amplitude, the vertical shift, the phase shift, and the parent. And we'll start with a relatively simple example. The parent is y equals cosine of x with a period of 6 pi, an amplitude of 3, a vertical shift of -2, and a phase shift of 0. The first thing we need to do is to orient ourselves vertically, and we see that there's a vertical shift of -2 and an amplitude of 3, so we have to be within 5. And so we can rather conveniently label the vertical axis so that we're running from -5 to +5. I think that the most convenient thing to do is to first identify the location of the vertical shift. And since the vertical shift is at -2, I'm just going to sketch in a little dotted guideline at y equals -2. And then given that the amplitude is 3, we need to go 3 units either side of -2. And so I'll make sort of an upper boundary at y equals 1, which is 3 units above, and a lower boundary here at y equals -5, which is 3 units below. And now all I need to do is sort of color inside the lines when I make my graph, and I'll be in good shape. The period is 6 pi, and there are a couple of ways to go with this, one of which would be to just count out by pi's until we get to 6 pi, and then to divide that in half, which would give us 3 pi, and further divide that in half, which would give us 3 pi over 2. The other alternative, which works in sort of all of these cases, is just to mark off 4 equal subdivisions and then label the fourth one with whatever your period is. Then halfway, of course, we would have half of that, so half of 6 pi is 3 pi, and then half of 3 pi is 3 pi over 2. And then if I wanted to label that third tick mark, I could just take 3 pi over 2 times 1, 2, 3. That would give me 9 pi over 2. And that's perfectly sufficient. But if I wanted to keep going, I could say there are 5 of those. 5 times 3 pi over 2 is 15 pi over 2. And I could label this one if I wanted. That's going to have to be -3 pi over 2. There's no phase shift, so we're actually ready to make our graph. We have to recall that the cosine starts at the top of its cycle. So in our case, the very top vertically is at 1, y equals 1, and we're going to begin there and go down. After a quarter period, we are at the middle. After half a period, we are at the bottom, and then back to the middle, and finally after a full period, we're at the top again. If we want to extend this a little bit in either direction, we're perfectly free to do that. And then it's just a matter of sketching in an appropriate wave that sort of goes through the values that we've indicated. So that's our first example. Our second example is a little more complicated because it involves also a phase shift. But we'll begin in the same fashion. We'll try to identify first a vertical scale, and we see that we have a vertical shift of 10 and an amplitude of 50. So we're probably going to want to mark ourselves off by, say, 10s. So I'll maybe locate 50 and -50, respectively, above and below. And now I know that the vertical shift is 10, so I'll make my sort of center guideline at y equals 10. And from there I'll go up 50. Well, 10 up 50 takes me to 60. So that'll be my upper boundary. And 10 minus 50 takes me to -40. That'll be my lower boundary. And now I'm set vertically. Again, I just have to color inside the lines. My period is 3 pi over 4, and I think we'll employ the method we did in the previous example, which is to just mark off 4 equal subintervals and label that fourth one as the period. So that's 3 pi over 4. If I cut that in half, half of 3 pi over 4 is going to be 3 pi over 8. Half of 3 pi over 8 is going to be 3 pi over 16. And of course, the cheap way to keep dividing fractions in half is just to double the denominator and then reduce them as necessary. I can figure out where this is if I just go 1, 2, 3 times 3 pi over 6. This, by the way, is also known as pi over 2. And so 3 pi, no, 16. I hope I said it right. I wrote it wrong. So 3 pi over 16. 3 of those is 9 pi over 16. You can label some other values if you want. Now, we've yet to take care of the phase shift, but I want to save that for very last. And I want to first look at what would happen if there were no phase shift. So we have a sine. The sine would begin in the middle and head up to the top. After half a period, back to the middle. 3/4 of a period to the bottom, and then back to the middle. And I can extend that a little bit in either direction if I have a mind to. So if there were no phase shift, my graph would look like this. And I find it helpful to dot in a little unshifted graph and then go ahead and shift that and get my final result. So the phase shift now is 3 pi over 16, and conveniently that's a quarter period. So all I really need to do is to take these key locations that we identified previously and just move them all the appropriate distance to the right, which is 3 pi over 16. And I can sort of stick another value there, so I go all the way to the left of my graph, and then draw myself a sine wave that hits those key values, and it should be one tick mark to the right of the one that we had first identified, the unshifted graph, and so here is our final result.